All right, here's the summary. So in number 9, we had a situation, a car traveling at a constant speed v in a circle. And we looked at what happened as the velocity vector changes around the circle and used some proportional reasoning to find out that the acceleration is proportional to the speed square. And then, if we look at this, number 10, if we keep the speed the same, we know the delta V arrow is going to be the same for both cases, but in the second case where the circle has twice the radius, it's going to have to travel twice the distance. So if the speed is the same and the distance is twice as much, it's going to take twice the time. Now if we look at this here through our proportional reasoning, the acceleration is going to be 1/2. So as the radius increases, we find that the acceleration will decrease, and we can say that it's inversely proportional. The acceleration is inversely proportional to the radius. Now if we take both ideas and combine them, we are going to get something referred to as the centripetal acceleration, which is equal to v squared over r. That's centrip, T-R-I-P, et al. Centripetal acceleration. The word centripetal means center seeking. Okay? And as we've been looking at, our change in velocity arrow or acceleration arrow is always pointing towards the center. So the centripetal acceleration is a mathematical way to determine the magnitude of an acceleration that is caused by the velocity vector that changes as an object travels in a circle. So anytime we are using Newton's second law, we can take, when you have the net force divided by the mass is equal to the acceleration. When things travel in a circle, just denote it with a small little c. So this is your centripetal acceleration, and whatever the net force equation is, depending on the situation, you can substitute in v squared over r. And example 1 has you apply this in variable form, and example number 5 is a mathematical one with definitive answers. So you guys are going to try those next and hand them in tomorrow.